So today what we're going to be doing is we're going to be going over heating and cooling curves, how to read them, and also kind of delving into what they indicate here. And heating and cooling curves are essentially just a special kind of graph that we're going to be using. And this is what a heating curve looks like. Now, on the heating curve, we know that we're going to be talking about some substance here. And for the sake of making it easy, because everyone knows the melting point and freezing point of water, we're going to say that this substance is water. And there's going to be two variables that we're going to be working with here. We are going to be working with temperature. So we're specifically going to be measuring the temperature of the substance, and that's going to be the variable that's being tested, and it's also going to be time. And time is going to be the variable on our x-axis, which means that we're actually going to allow time to go forward on this substance as we give it a constant amount of energy. So think about this as, you're putting some water on the boil, you're setting the temperature of the stove to, 400 degrees, and then you're just letting it sit. So it's set at the same exact temperature. So it's increasing the amount of energy it's getting by a set amount. And the amount of energy is not changing, and that's staying constant. So the only thing that's changing is how long that water is in there. Now, what we're going to start with here, we're going to say that this is a really, really low temperature. So we're going to say that this is something like negative 50, negative 32 degrees. Now, if it's water, what state is it going to be in when it's at negative 50 degrees? It's going to be in a solid. So first, if it's at negative 50 degrees, we have to heat that solid. And so this first line segment that goes from A to B is just going to be our solid heating, okay? And then I want you to notice something here, that after we have heated our solid, and let's say that this is the 0 degrees Celsius here, after we have heated our solid, we end up getting this flat part right here. And this flat part is one of the big things that we want to analyze here, because we would expect that if we keep adding energy that the temperature should keep going up. But instead we see the temperature flattens out. Now what's happening here is that we're actually undergoing a phase change right here. And the phase change that is happening is that this solid is now turning into a liquid. So now we're going to go ahead and label this as that process, which is melting. And notice that the temperature of it didn't change at all. So while a phase change is happening, you're not going to be seeing any change in temperature, because all of that energy that is going into that solution is going into the process of doing the phase change. After it has completely melted, and that's where C is. C is it has completely melted. Then we're going to continue adding energy to it. Now, what happens when you add energy to a liquid? The liquid itself is going to heat. So from C to D, we're going to have liquid heating. Okay? And notice here, we have a pause again in our temperature. So our temperature has flattened out again. From here, we could probably take a guess that this flattening out is likely going to be a phase change. Now, what's the phase change going from liquid to something that's more energetic? That's right, that's going to be evaporation. So right here, this is going to be evaporation. So that transition between it going from a liquid to a gas is going to take all of that energy. The last step right here is that we're going to go from having all gas, and if we continue to heat that gas, well, the temperature of that gas is going to heat. And so that's going to be gas heat. One of the big things that I want to make sure, and you guys probably already have it by now, is that the phase changes are the flat points of our graph right here. So these flat points are going to be our phase changes. And even though energy was added at a constant rate, because it had to go through this phase change, the temperature stayed the same. Now you can end up doing this in the reverse way. This right here is our heating curve, but you could theoretically also have a cooling curve. And notice that this goes the same way, that the gas is warm and it gets cooled. Then you have a phase change. Then the liquid cools, and then you have a phase change, and it goes that way until you have a solid cooling down. So take note of that both a heating curve and a cooling curve is going to work in the same manner. Now, there are two terms that we did not go over yet, and that's deposition and sublimation. A deposition is going to be when a gas goes directly to a solid, and sublimation is going to be a solid phase changing directly to a gas. If you guys have ever seen dry ice, that's an example of sublimation right there, that the carbon dioxide is a solid and it will instantly turn into a gas if it gets warm enough. The next thing that I want to talk to you about is a phase change diagram. And the phase change diagram is just showing you what state a particular compound is going to be in based off of two different functions. And the two functions that we're going to be talking about with this is going to be atmosphere and temperature. So if you have a lot of pressure on you, that's going to change what kind of boiling point or melting point that you're going to be at. And before we go too far in, what I want you to do is take note of a couple of these lines. And these lines are going to be important for determining some things that are going on. This line right here, that's in between the solid and liquid, this is our melting point and freezing point line. So anything that crosses this line is the melting point or freezing point. The line that's right here is between liquid and gas. This is our evaporation point or condensation point. Okay, so when it crosses from liquid to a gas, that's evaporation. From gas to a liquid, that's condensation. And the last one is going to be the line with the two terms that we just learned about, which is sublimation, solid going to a gas, or deposition, gas going directly to a solid. So that particular phase change is just down right here. There are some things about this graph that may make some things that you've seen in popular culture make a little bit more sense to you. So one of the things that if you end up going to a higher altitude, so for instance, I grew up in Denver, Colorado, the boiling point for water, or the point for a liquid transitioning to a gas, ends up being significantly lower in Colorado. It ends up being about a degree or two off from the temperature at sea level. So because there's less pressure at 1 mile up, water boils at a slightly lower temperature, because when we go from right here across, we would have to go to 100 degrees. If we did a little bit lower pressure, notice that it's a little bit less degree. Okay? The other thing that this is really important for, and it may help you explain, is if you watch a scientific movie where you have an astronaut and that their suit ends up getting punctured, or there's an evacuation or an airlock, you'll notice that, often they will have some image of the astronaut exploding from the outside. And the idea is that the astronaut is going from really, really high pressure, so 1 atmosphere, to no pressure, and he's going and also going from a high temperature to a lower temperature. So they're basically saying that the astronaut is going from a solid state to a gas state, which, as you can imagine, is not so great for the human body. Now, this type of diagram, there are a couple of types of questions that we like to have on this type right here. And we're going to go over those different types of questions right here. Alright, so we'll go ahead and look at question 1. And question 1 is asking us to discover what the state of this compound is going to be at 25 degrees and 75 atmospheres. So this is the first type of question, and it's a basic locate where it's supposed to be. So it's really just testing whether or not you can read the graph, and there's nothing really special about it. So you have to just go ahead and think, okay, where is 75 atmospheres going to be? Okay, 73 is here, so it's going to be here. And then where is 25 degrees going to be? It's going to be here, so about here and here. So it looks like it's in the liquid state. So number 1 would end up being liquid. The next question is the substance is at 50 atmospheres and is being cooled from 0 degrees to negative 80 degrees. Okay, so 50 atmospheres, we're going to have to approximate where 50 atmospheres is. Okay, it looks like 50 atmospheres, we're going to say it's, right about here or so. We could say right here. And it's being cooled or from 0 degrees, so, this is negative 56.4, so 0's got to be somewhere over here, to negative 80. And this type of question, and I don't have it listed here, it would be, what is the phase change that's happening here? So if it's going from 0 to negative 80, we would say, it's going from a liquid to a solid. Therefore, it's undergoing the freezing phase change. The last question, number 3, is saying that a substance is at negative 200 degrees. Okay, so it's really cold and 4 atmospheres. So it's right about here. Once it reaches 25 degrees, so it's being heated from negative 200 to 25 degrees. It has its pressure increased to 25 atmospheres. Now it's asking what phase changes it goes through. So this one, it goes from about 4 atmospheres, and it goes from negative 200 to 25, so it goes along here. And notice it crosses this line, so it goes from solid to a gas, so it's undergoing sublimation. And then it's saying that it increases to 25 atmospheres, so it's going to go up here, and we would go ahead and say, alright, this is likely going to end up undergoing a condensation as well. So it's going from a solid to a gas, that's our sublimation, and then from a gas to a liquid, that would be our condensation. So we would say it undergoes sublimation and condensation. And these are really the types of questions that you could see for this type of phase change diagram. More often than not, you'll look at a phase change diagram more to answer questions like number 1 to see what kind of a substance it is, but knowing how to read it as the thing moves is also useful as well. That's going to end up closing out this lesson. A reminder that we went over phase change diagrams, and we also went over heating and cooling curve, which is going to be needed for labs later on in this section.